Hi, I'm Gracie, and I'm part of P3, an FTC team in Fenton, Missouri. And I'm going to give a presentation on how to use the new FTC machine learning to identify the TSE. So when setting up the machine learning, you first need to have a first dashboard account, and it needs to be on a team roster. So that means that if you're a student, you have to be added to the team before being able to use the machine learning software. So to add students, the coach goes to this link here, and then they have to click on their teams and then go to, and then go to users and add a role. And then your role will be a team member. And just a note, students are not able to upload video to the machine learning workspace. So a coach has to do that. Should I keep going or?
Keep going.
So, and then once you have all of your students added to the workspace, then you can click on this link to take you to the machine learning workspace. Okay.
Oops.
So when designing your TSE, just a few tips to have it be identified as best as you can by the machine learning algorithm is to have contrasting elements. So on ours, you can see we put little pandas. And this could also just be like multiple colors, stripes, patterns, anything like that. And then using a color that's bright and very different from the gray mats will also help your robot pick up the TSE. And as just a reminder of the sizing, the TSE has to be greater than 3 by 3 by 4 inches and smaller than 4 by 4 by 8 inches. Then the next step in creating your custom TensorFlow model is to record your video. And then for the best results, you'll want to record that video with the same camera in the same position it will be during the autonomous period. So we literally just unplugged our camera from the control hub and plugged it into the computer on the field and recorded our video. And then you'll also want to be recording with the TSE in different positions and different lighting conditions and with like different backgrounds. And also important is to make sure that the TSE is in all combinations. So on the left and the right side, on the red and the blue alliance, and in all 3 different squares. And also include shots that don't contain a TSE at all, so that the algorithm knows what it, so that the algorithm can know for sure if it's detecting something or not. And our team, instead of taking a continuous video while we were moving the TSE around, we used a Windows laptop, which has a pause feature. So you can take small snippets of video, pause and move the TSE, and then continue recording, which will make the next step, drawing boundary boxes, much easier. So once you have your videos, an adult user will have to upload the videos to the machine learning toolset by clicking on Upload Video in the Videos tab. And let's see if the machine learning will let us in right now. It looks like it is, the site is down right now. Oh, okay, there we go. So yes, under the Videos tab, you'll click on Upload Video, choose your video, and then upload it. And then once you have your videos uploaded, you're going to click on them. And for each frame of the video, and as you can see, this video is about 30 seconds and it has 830 frames. And for each video, you're going to draw a bounding box around your TSE and then label it. And these labels must be the exact same label for every frame. If the labels are different, then the model will treat these as different objects and it won't be able to identify it as well. And then once you identify a few frames with the same thing, you'll be able to start tracking. And what that means is that the software will begin tracking these for you. So you click on Start Tracking and it loads. And then what's happening is that as it goes through each of these frames, it's going to move the bounding box as it is able to keep it around so that you don't have to manually draw a box for 830 frames. Okay. Then once all of the videos have been labeled, you can select back in the videos tab on the main page. You can select different videos and create a data set by clicking Produce Dataset. And then for the percentage of frames for training versus evaluation, what this means is that website will automatically take a percentage of your videos and use them for actually training the model. And then for evaluating the model, which means it'll see how accurate the model is at detecting images. So the recommended percentages for these are 20 and 80. And then the description will just be the title. So we'll label this TSE videos. And then once again, a very important step is making sure that the labels are identical for each image. And if you're in the one second. Under the dataset tab, you can see all the labels included in the dataset. So here you see the TSE, and if there was a single frame where it was accidentally marked TS or TSA, then there would be two different labels here, and you'd know that there's a typo, and you'll have to go back and fix it. And the next step is actually training the model. So you'll select the data set that you want to use, and remember that the model has to be the labels have to be identical for these data sets if you're using more than one. So you'll select the model and click Start Training, and then you'll have a few different options here. So the starting model, it's recommended that you just keep it with the SSD MobileNet version 2 320 by 320, and that if you can experiment with the others, but this is the default and recommended model. And then the number of training steps is related to the number of epochs that will be completed. It is recommended that when you train a machine learning algorithm, to use 100 epochs or more. And down here, it'll tell you how many epochs the steps will complete. With this starting model, each batch size will be 32 images. So it'll take 43 images to complete one epoch, which is a full cycle through the training data. So right now we only have 70 epochs. We'll want to increase this to over 100. Next is the maximum training time. Each team has an allocated amount of minutes, and you do not want to use all of your minutes up in the very first training set. So if you I think the original starting is 240 minutes, 4 hours. So you'll have to choose what portion of training time you want to use, and then the training time. It is using this default model. Every 60 minutes, 1 hour will run through roughly 3,000 steps. So to go through 4,040, we'll need more than an hour's worth of training time. And if your model training ends after completing the specified number of steps, then the remaining training time will be given back. But if your steps are not completed, then the model will be saved using the last check mark of 100 steps. So if the model is out of time and it has completed, say, 545 steps, the last 45 steps will not count. Once your model is completed, you'll need to go over to the model tab and you'll download the model. And also you can look and see how accurate your model is by looking at the graphs, which take a bit to load. So you can see here the learning rate will begin relatively low and then increase until about the middle of the training period, and then the learning rate will decrease. And the learning rate is how much of a change the algorithm goes through each step. And then the classification loss, all losses, you want to be very close to 0. A model that's closer to 0 will be more accurate than a model that has a loss higher than 0 or closer to 1. On the other hand, you want the precision to be very close to 1 in an accurate model. So once your model has downloaded, you'll go to the you'll go to the code editor and go to the manage tab. And unfortunately, you cannot be on the code editor while still being on Zoom. So I cannot show this part, but you'll go to the manage tab and scroll to a section called upload TensorFlow light model file. And then you'll just select the model from your file explorer and click upload. And then if you're using OnBot Java, you'll create a program with one of these samples, depending on which camera you're planning on using. And if you're using blocks programming, there is only one sample that is used with a custom model, and this is the name. Right. So next, I'll walk you through setting up these programs, first in blocks and then in OnBot. Unfortunately, I do not have knowledge of Android Studio, so you'll have to rely on the user manual or other videos for that. But for the blocks programming, the first step is to either disable this first block and enable the second block. And you do this by right-clicking on the block and selecting enable or disable. And if you're using a webcam, then you have to make sure that the second block is enabled. And if you're using the robot camera, then the program default is using that, so you don't have to, so you can ignore this step. So then if you're using a webcam, make sure that the right webcam is selected, and this is only needed if your webcam configuration has been changed from the default. And then you'll scroll down to where it says call TensorFlow object detection custom model from file, and you'll need to change this TF-Lite model file name to the name of the file that you just uploaded under the manage tab. Next, you'll replace the, you can see here that the list is created with ball, and that is the label that is used in the original TensorFlow model. And we'll need to replace that with whatever label you used during your training. And once again, the spelling must be exactly the same. And if multiple labels were used, if you have multiple different TSEs, or if you used a block or a duck as well, then you can click on this little settings, this blue settings gear, and add more items for each additional label. Next, you can adjust the minimum confidence, which is the lowest threshold confidence level needed for the model to identify an object. So a lower value will result in more false positive identifications where the robot thinks there is a TSE and there isn't, but higher values will result in more false negatives in which there is a TSE, but the robot does not see it. Another variable that you can change is the magnification, and this relates to the amount of ignored space on the border of each frame that the camera sees. So a higher magnification value means that the field of view is smaller. For our robot, I used a value of 1 so that the robot could see 2 of the 3 squares at a time. Any higher values and the robot could only see 1 of the 3 squares. That is all that you need to do for the blocks programming. Next, I'll talk about for the OnBot. And for the OnBot, I used a webcam. So there might be an additional step in here that people who use the robot camera can ignore. So the first step on the OnBot Java is to replace the highlighted text here to the name of the file that you just uploaded under the Management tab. And next, you'll replace the labels with whatever was used during training. And this is just to show what it should look like. And then for this next step, you can either follow these directions in the comments and obtain a Vuforia key, or you can just delete this text in quotations so that the Vuforia key is equal to a blank space. Next, you'll need to replace the set model from file, which uses the default model on the robot hub, with load model from asset, which will upload it from the manage tab. Again, you'll need to make sure that the web camera, if you're using a web camera, is with the same name as in your configuration file. Here is where you can change the confidence level, which again is the lowest threshold needed for the model to identify an object. And then the setting zoom is in the same block as the aspect ratio. So if you want to change the zoom, it's the first value, not the second. Okay. So after building your model, you should be able to use your driver hub or your phone and test it out. So the data that I used here shows the confidence, and then this 31 here is the, it is the left value. So you can use either the left side of the boundary box, the right side, the top, the bottom, the width, the height, and there are more. And these are all methods that can be found on the recognition, the object that the robot creates when it sees an object. And these are all how you call them in OnBot, but if you're on blocks, then you'll go under utilities to TensorFlow object detection and recognition, and then you can see all of the different variables. So, and this is just how you would call it on a OnBot program. So the ways that you can, possible ways that you can actually use this custom built model to actually use it in the autonomous. So in my program, I use the left side of the automatically drawn boundary box detected in the program, and the robot is positioned at the start so that the webcam can see 2 of the 3 squares. It's just not far back enough to see all 3 at a time. So then if the TSC is not identified, then by process of elimination, it has to be in the 3rd square. And if the left side of the TSE is greater than 400 pixels from the left edge of the image, then it is the 2nd square, and otherwise it's on the 1st square. And I repeat the above conditional about 100 times, since it often takes a second to identify the TSE, and repeating it 100 times barely takes half of a second. So this method works very well for my robot, but each robot's different. So you could also move the robot to see all 3 squares, or use a different edge or method to identify the position of your team's TSE. Be creative. There's a way that anyone can see this. Here are some resources to help with building your custom model. This is the GitHub. So you can see problems that have popped up and discussions that are occurring. And then this is just a link to the user manual, which also gives an Android Studio setup if you're using Android Studio. And then here's the P3 team email if you have any questions.